Today is the part 2 in the series of circle and its properties. We shall learn in this session about chords and its characteristics through paper folding activity. Each child should bring about 7 to 8 paper cutouts of circles from white sheets for this activity. Let us start with two interesting questions. Suppose a small arc has been drawn on your notebook. As you know, an arc is part of a circle. How can we complete the whole circle when we have just a small arc? We have to think where the center of this arc is. If we get the center, then we can complete this circle. Another question. Suppose 3 points are lying haphazardly on a plane and we have to complete a circle touching all the 3 points. How to do that? Again the question comes, if we get the center, then we can draw these circles. All these queries will be answered once you have the background knowledge of chords and its properties. That will help you to solve these interesting problems. Let us start with paper cutouts of circles. Each child should pick up a paper cutout that he or she has brought. So this is the first one. What we do, along with the children, we instruct them to fold at one end so that we can get a chord. You can see this is a chord. How is this a chord? What is chord? Chord is the line segment joining any 2 points on the circle. So this is one point, that is another point. We have joined it by paper folding. So which one is our chord? This is our chord. Now if we keep on folding along this line and the children will fold along with the teacher, keep on folding. And when we open, it is clear that we have got a number of chords, each one joining 2 points on the circle. So now we change the direction of the folding. So we take another folding here. This is another chord joining this point and do the same folding as we did just now. Just keep on folding. And again if we open, we have got another set of chords. Now these chords are crisscrossing the earlier chords. If we go this way, by folding anywhere and just go on folding, we will get infinite number of chords. So we can say chords are infinite in number. It can go from any point to any point on the circle. So next we take another circle. Children should do the notebooking on this later altogether. Otherwise they will forget the characteristics of chord. So we take a second one. When they are drawing the circle, each one has to mark the center with a pencil. Otherwise it will be difficult to do these activities. So this is the center, to mark the center like this. If we fold along the center, then what we will get? We will get the diameter of the circle. So I can see from here, this is the center. So children will draw along with the teachers. And yes, we have folded it correctly because these two parts are absolutely symmetrical, mirror image of each other. So we have got the diameter. What is diameter? Just to recapitulate, any line segment that passes through the center of the circle and its 2 end points lie on the circle. So this is one diameter. So now we are concentrating on chords. So one fold and then we fold again along the arc. And when we open it, what are these two? This is one chord joining any 2 points on the circle. This is another chord joining these 2 points on the circle, and also diameter is a chord because it is also joining 2 points on the circle. Now what we see, these two are equal chords because we have folded it together and we got 2 equal chords. These two are equal chords. We can easily see these two are equal. Let me fold it this way. So these two are absolutely equal chords. Now can we estimate the distance of these equal chords from the center? Center is here, and these two equal chords, can we say they are at equal distance from the center? Yes, they are. So that is another property, that equal chords are at equal distance from the center. If you draw a perpendicular here and a perpendicular here, they will absolutely overlap on each other. So this is one property. Equal chords are at equal distance. Another is diameter is the longest chord. Thirdly, from this simple activity we can see that equal chords have corresponding equal minor arc as well as major arc. So minor arc, not only minor arc, the minor segment will also be equal. So that is another property, equal length of minor arc and equal length of major arc. That means for this chord, this is the minor arc and this is the major arc. And for this chord, this is the minor arc and this is the major arc. And because this minor arc and this minor arc are equal in length, major arc of this chord and major arc of this chord are also equal in length. Next, what we can see from this activity, if we fold some more, let us fold some more chords out of this circle. If we now open, what do we see? We can see that smaller chords are towards the periphery, longer chords are towards the center. So that is another property. Between any two chords, the longer chord is always towards the center. That is another important property of circles. Now you can say that you have folded it parallel to the diameter. Probably that is why it is clear that the two equal chords are at equal distance from the center. Okay, let's then fold it in one corner because we want two equal chords. So these are two equal chords. These two are equal chords. It is not parallel to the diameter. So let us see whether these two equal chords are still at same distance from the center. How do we find the distance of these chords from the center? By drawing a perpendicular. Let us fold the perpendicular. So if we just fold the chords, each child should do this with hands, otherwise demonstration by the teachers in front of them will serve no purpose. They won't be able to understand what the teacher is doing. So now we open. This is a perpendicular from center to this chord, and this is also a perpendicular from the center on this chord. Whether it is perpendicular or not, this one we can show you by a protractor. And for that, we shall join these 2 points with a pencil. During folding there may be some error, but it will be very close to 90 degree. Now if we measure with protractor, this line is on the chord, we can easily see this 90 degree is matching with the perpendicular. So this is 90 degree. This angle is 90 degree. That means that gives the distance of this chord from the center because it's a perpendicular. Same with this side. We are placing this line on the chord. You can easily see this is also 90 degree. So these two are perpendiculars. Now let us see if these two perpendiculars are equal or not. What we are trying to see, whether equal chords lie at equal distance from the center. So that is our goal, to see whether these two perpendiculars are same in length. Yes, even if we draw two equal chords having an angle with the diameter, even then the chords are at equal distance from the center. With this we can find some interesting property. If we fold a bisector to any chord, it will always pass through the center. How did we do the bisector? This is the chord, and for bisecting the chord we have to match the endpoints with each other like this and press it properly. This will give us the perpendicular bisector. No doubt about that. Bisector of the chord, bisector of this chord also, this chord also. Perpendicular bisectors of all chords pass through the center. That is a very interesting fact, and on that lies the solution of these two problems. So let us see carefully. These two perpendicular bisectors are crossing the center. Another point is, if all bisectors from center to the chord, they are perpendicular also. The converse is also true. Perpendiculars dropped from center to a chord always bisects the chord. Let us see if this property holds good for another set of equal chords. So again we are folding two equal chords. Children should follow the teacher. So these two are equal chords. Let us now again bisect the chord by bringing the two endpoints together. This will be the bisector.
And now open.
So this is the bisector of this chord and this is the bisector of this chord. So this bisector also is going to the center and this bisector also is going through the center. These two we can obviously see are right angle or 90 degree. This is one right angle and that is a right angle. Perpendicular bisectors of all chords pass through the center. We have no doubt about that. These two also, the perpendicular bisectors of these two chords pass through the center, and perpendicular bisectors of these two chords, these are the perpendicular bisector of these two chords, will pass through the center. However sets of chords we take, perpendicular bisector will always pass through the center. That is a very important property. The children should note down later once the activity is finished. We can now try to solve this problem. What can we do? As we have seen, all the perpendicular bisectors of chords pass through the center. We can use this property to draw the complete circle of this arc. Let us take a point here. Let us mark this one as A, this point as P, and this one as C. And we draw two chords, one from A to P. AP is a chord, another is P to C. I am not using ruler because I want to just discuss the principle. So AP is one chord, PC is one chord. What to do now? To get the center of this arc, if we draw perpendicular bisector of this chord and if we draw a perpendicular bisector of this chord, they will meet at the center because both of them have to pass to the center by its property. Now if we draw the perpendicular bisector of this chord and perpendicular bisector, they have to meet somewhere at the center of this whole circle. And with that as the center and taking this as the radius, if we draw a circle, that will give us the complete circle. Children should try to draw it in their notebook with proper protractor and ruler. And for this one, probably you can guess what we are going to do. Because they will come on the circumference of a circle, that is what they are asking from us. That means if we join these 2 points, that is one chord, and if we join this with this point, that is another chord. Can we now see what we are going to do? Again, we are naming it as P, Q, R. And they are asking us to draw a circle through all these points. The circumference will lie on P, Q and R. If we do that, then this is one chord and this is another chord. And what are we going to do? Same thing, we have to draw a perpendicular bisector through this QR, thinking it will be a chord, and another perpendicular bisector from here which will cross at the center. We have to do it with proper compass and ruler. If this is the center, then perpendicular bisector, as we know, the center O will be equidistant from Q and R because this is the perpendicular bisector. On the perpendicular bisector, all points are equidistant from the end points of the line segment to which the perpendicular bisector is drawn. So Q and R is equidistant from O. Again, for this line segment, if this is the perpendicular bisector, then this point will be equidistant from Q and P. So O is equidistant from R, Q and P. That means this is the center of the circle that can be drawn through all these points. This is not to the scale. When drawn properly, it will look like this, and O will be the center of the circle. All these properties that they have learned today, that has to be noted down in their notebook. With this simple activity, they can really learn a lot of the properties of chords through which they can solve problem later in their next step. So children should write in their notebook all these properties of chords as they have verified through this activity. Number 1, chords of a circle are the line segments connecting any 2 points on the circumference of the circle. 2, chords are infinite in number. Number 3, diameter is the longest chord. 4, of any 2 chords of a circle, longer chord will be nearer to the center. Number 5, equal chords of a circle are equidistant from the center. And conversely, chords equidistant from the center of a circle are equal in length. Number 6, every chord has a corresponding minor arc and a major arc. When diameter is the chord, both arcs are equal. Then there are no major arc or minor arc. The equal arcs are called semicircles. Number 7. If two chords of a circle are equal, then their corresponding major arcs and minor arcs are also equal. Converse is also true. Finally, perpendicular bisectors of all chords in a circle pass through the center. And we have demonstrated all these properties with the children in today's session.